In the diagram, circle C lies on the coordinate plane with its center at C 2, -2, and the radius of circle C is 4 units. Point P appears to lie on circle C at point 6, -2. Amelia must prove that the point P lies on the circle. What steps could Amelia take to carry out this proof? There's more than one correct answer choice for question A. Select all correct answer choices for question A. Then select one answer choice for question B. Okay, so we could duplicate this and look and see what they have to say about proving a point is on a circle. So right here, so we could say that it's saying right here to use the equation of the circle, which means the radius is 4 and the center is at -1, 1. So we could use the formula of a circle, which would be, we can create that. So since the center x coordinate is 2, h is 2. Since the center y coordinate is -2, it would end up being y plus 2. And the radius is 4 units. So 4 squared is 16. So that is the equation for our circle. And substituting the coordinates of P for x and y, if the resulting equation true, then P must lie on the circle. So what that is saying is that we could substitute the values of P. So the P's x coordinate is 6, so we could substitute this in for 6. And we could substitute the y coordinate, -2, in for y. And they're saying that if this point does lie on the equation on the circle, this will come out to be 16. So we can jump over to our calculator, and again, remember that those stay as squareds, because when I'm copying mine over, they do not. So I can click go, and this will simplify it for me. It does come out to be 16. So 16 does equal 16, so yes, it will lie on the circle. So that's one way. They said that there was more than one correct answer choice for question A. I had taken kind of cliff notes. So there's another way, and that is we can, if point B is on the circle, then the distance of AB must equal 4. So we can use the distance formula to find the distance of AB. So what that is saying is if this point lies on our circle, then the distance of CP has to also equal what the radius is, which would be 4. So we would use a distance formula. So she can use the distance formula of CP is equal to, so now we've got to figure out what the distance formula is for this particular case. So the distance formula, if we cannot remember what that is, you would go up to key terms, or actually, one better, I would just Google search. I know I have one in the tab up here for announcements under website resources. It is this is how to simplify the distance formula. So I would just copy that, and then I would jump back to our problem to find the length of CP. So once I can remember what the coordinates are, we have point C, which is our center, which is at 2, -2. And I believe the reason this is showing up that way is because I have it zoomed in so much. Okay. Nope. So X coordinate, Y coordinate. The other point would be point P, which has the coordinates of 6, -2. Click calculate, and this will show us the steps. So we're looking for the distance of CP, which is equal to 6 minus 2 plus -2 minus a -2. Okay, so since I'm not seeing that, that is telling me that they actually used point P as the first point and point C as the second point. So then we see 2 minus 6 plus -2 minus a -2 squared, so it's matching this one. And it does come out to be 4, which is the radius length, so point P does lie on the circle. So these are two ways we can use answer if a point lies on the circle.